Download this code from codegive.com, link in the description below. Bro joined the wrong server, a deep dive into client-server communication and troubleshooting. This tutorial explores the common scenario where a client, let's call it Bro, unexpectedly connects to the wrong server. This is a common issue in networked applications, and understanding the underlying causes and how to debug them is crucial for building robust and reliable systems. We'll cover common causes, coding examples, primarily in Python, but principles apply across languages, debugging techniques, and best practices to prevent this problem. Understanding the core problem **. The root of Bro joining the wrong server lies in the client's configuration and its ability to correctly identify and connect to the intended server. This involves several key components. 1. Server identification **. The client needs a way to uniquely identify the server. This is typically done using *IP address **, the numerical address of the server on the network, example 192.168.1.10, or 203.0.113.45. Domain name **, a human readable name that resolves to an IP address, example myserver.example.com. DNS, domain name system, translates domain names to IP addresses. Port number **, a specific doorway on the server to listen for connections, example 80 for HTTP, 443 for HTTPS, 21 for FTP. 2. Client configuration **. The client application needs to be configured with the correct server identification information. This configuration can be hard-coded **. The server details are directly written into the client's code. This is generally not recommended except for very specific, controlled scenarios. Configuration file **. The server details are stored in a separate file, example config.ini, settings.json, that the client reads at runtime. This offers flexibility and avoids recompiling the client for server changes. Command line arguments **. The server details are provided as arguments when the client is launched. Useful for testing and overriding default settings. Environment variables **. The server details are stored as environment variables on the system where the client is running. Good for deployment and containerized environments. User interface, UI. The user manually enters the server details into a UI when the client starts. Suitable for applications where server selection is dynamic. 3. Network connectivity **. The client must have a working network connection and be able to reach the server's IP address and port. Firewalls, routers, and network configurations can block or redirect connections. Common causes of Bro joining the wrong server **. Incorrect server configuration **. This is the most frequent culprit. The client's configuration might contain wrong IP address **. A typo in the IP address. Wrong domain name **. A typo in the domain name, or an outdated DNS record. Wrong port number **. The client is trying to connect to the wrong port on the server. DNS resolution issues **. If the client uses a domain name, DNS might not be resolving it to the correct IP address. This could be due to DNS server issues **. The client's configured DNS server is unavailable or returning incorrect information. Cached DNS records **. The client or the network has cached an outdated DNS record. DNS spoofing, man-in-the-middle. A malicious actor is intercepting DNS requests and providing a false IP address. Less common, but a security concern. Firewall interference **. A firewall on the client's machine, the server's machine, or somewhere in between might be blocking the connection. Asterisk network routing issues. Asterisk the network might not be configured to route traffic correctly between the client and the server. Asterisk load balancer configuration. Asterisk in systems with load balancers, the client might be directed to a different server than expected. This can be intentional for distribution, but could also be a configuration error. Asterisk server configuration. Asterisk the server itself might be misconfigured. Asterisk server not listening. Asterisk the server application isn't running or isn't listening on the expected port. Asterisk server binds to wrong interface. Asterisk the server is bound to the wrong network interface, example only listening on local host instead of a public interface. Asterisk client-side bugs. Asterisk while less common, bugs in the client code can cause it to misinterpret configuration data or construct incorrect connection requests. Asterisk environment differences. Asterisk the client might be configured correctly in one environment, example development, but not in another, example production. This is often due to hard-coded values or incorrect configuration deployment. Asterisk proxy server issues. Asterisk if a proxy server is involved, the client might be incorrectly configured to use or bypass the proxy. Code examples, Python. Let's illustrate with a simple client-server example using Python socket module. 1. Basic server, server.py. 2. Basic client, client.py. Illustrative scenarios and debugging. Asterisk. Scenario 1, incorrect IP address in client. Asterisk problem. Asterisk in client.py, host is set to 127.0.0.1, localhost, but you want to connect to a server running on a different machine with IP address 192.168.1.100. Asterisk debugging. Asterisk. 1. Inspect client configuration. Asterisk examine the host variable in client.py. Is it the correct IP address of the server? 2. Ping the server. Asterisk from the client machine, use the ping command, ping 192.168.1.100, to verify that the client can reach the server's IP address. If the ping fails, there's a network connectivity problem. 3. Change the client. Asterisk modify client.py to set host equals 192.168.1.100 and rerun the client. Scenario 2, incorrect port number in client. Asterisk problem. Asterisk the server is listening on port 65432, but the client is trying to connect to port 80. Asterisk debugging. Asterisk. 1. Inspect server configuration. Asterisk examine the server code, server.py, to verify the port number it's listening on. 2. Inspect client configuration. Asterisk examine the port variable in client.py. Is it the same as the server's port? 3. Change the client. Asterisk modify client.py to set port equals 65432 and rerun the client. Scenario 3, server not running. Asterisk problem. Asterisk the server program, server.py, hasn't been started. Asterisk debugging. Asterisk. 1. Verify server process. Asterisk check if the server process is running on the server machine. Use commands like ps auxiliary grep server.py, Linux/Mac OS, or Task Manager, Windows, to check. 2. Start the server. Asterisk run the server.py script. Scenario 4, firewall blocking the connection. Asterisk problem. Asterisk a firewall is blocking the client from connecting to the server's port. Asterisk debugging. Asterisk. 1. Check client-side firewall. Asterisk on the client machine, check the firewall settings, Windows Firewall, UFO on Linux, etc., to ensure that outgoing connections to the server's IP address and port are allowed. Temporarily disabling the firewall, for testing purposes only, can help diagnose if the firewall is the problem. 2. Check server-side firewall. Asterisk on the server machine, check the firewall settings to ensure that incoming connections on the server's port are allowed. 3. Network firewall *. If the client and server are on different networks, check for firewalls between the networks, example on routers or dedicated firewall devices. 4. Firewall logs *. Many firewalls have logging capabilities. Examine the firewall logs for entries that might indicate a blocked connection. Scenario 5, DNS resolution failure. Problem The client is using a domain name, example measurver.example.com, but DNS is not resolving it to the correct IP address. Debugging 1. Use nslookup or dig on the client machine. Use the nslookup or dig commands to query the DNS server for the domain name. For example, or verify that the IP address returned by the DNS query is the correct IP address of the server. 2. Check /etc/resolve.conf, Linux on Linux systems. The /etc/resolve.conf file specifies the DNS servers used by the system. Make sure this file contains valid DNS server addresses. 3. Flush DNS cache *. The client or the network might have cached an outdated DNS record. Try flushing the DNS cache. Windows IP protocol configuration /flushdns. Mac OS sudo scotchy util flush cache, sudo killal hupm DNS responder. Linux The command varies depending on the distribution, example sudo systemd resolve flush caches on systemd-based systems. 4. Test with IP address * temporarily bypass DNS by using the server's IP address directly in the client configuration. If the client connects successfully with the IP address but fails with the domain name, the problem is likely with DNS. 5. Check for host file entry * on your client machine. Examine your host file. It will be c/windows/system32/drivers/etc/hosts on Windows, or /etc/hosts on Linux /Mac OS. If there is an entry for your domain name that maps to the wrong IP address, that is the problem. Remove or correct the entry. Scenario 6, server binds to the wrong interface. Problem The server is only listening on the loopback interface, 127.0.0.1, and not on a public interface, example 192.168.1.100. Debugging 1. Examine server code * in the server code, server.py, check the host variable used in s.bind, host, port. If host is set to 127.0.0.1, the server is only listening on localhost. 2. Change server binding * to listen on all interfaces, set host equals 0.0.0.0 in the server code. This will make the server accessible from any IP address on the network. However, be cautious about security implications if you're making the server publicly accessible. 3. Verify listening ports * use netstattooln, Linux, or netstatin, Windows, on the server to see which addresses and ports the server is listening on. Look for the process associated with the server and verify that it's listening on the correct address and port. Best practices to prevent bro joining the wrong server *. 1. Configuration management *. Avoid hardcoding *. Never hardcode server details directly into the client code. Use configuration files, environment variables, or command line arguments. Centralized configuration *. Consider using a centralized configuration management system, example console, act, zookeeper, to manage server details for multiple clients. Asterisk environment specific configuration asterisk use different configuration files or environment variables for different environments, development, testing, production. Asterisk configuration validation asterisk implement validation checks to ensure that the server details in the configuration are valid, example IP address format, port number range. Asterisk version control asterisk store configuration files in version control, Git, to track changes and make it easy to revert to previous configurations. 2 Error handling and logging asterisk catch connection errors asterisk use try, except blocks to catch potential connection errors, example connection refused error, socket.get-error, in the client code. Log connection attempts log all connection attempts, including the server details used, the result of the connection attempt, success or failure, and any error messages. This is invaluable for debugging. Detailed error messages provide informative error messages to the user when a connection fails, explaining the possible causes of the problem. Don't just say connection failed. Say connection to server 192.168.1.100 on port 65432 failed. Please check your network connection and server configuration. 3 Testing and validation unit tests write unit tests to verify that the client code correctly parses the configuration data and constructs the correct connection requests. Integration tests write integration tests to verify that the client can successfully connect to a running server in a test environment. End-to-end tests perform end-to-end tests to simulate a real-world scenario and verify that the entire system, client, server, network, is working correctly. 4 Security considerations encryption use encryption, example TLS/SSL, to protect the data exchanged between the client and the server from eavesdropping and tampering. Authentication implement authentication to verify the identity of the client and the server. This prevents unauthorized clients from connecting to the server. Authorization implement authorization to control what actions a client is allowed to perform on the server. 5 Use abstraction layers consider using high-level networking libraries that abstract away the complexities of raw sockets. Frameworks like ZeroMQ, gRPC, and similar provide higher-level APIs that make it easier to handle connection management, error handling, and data serialization. They often offer features like automatic reconnection, load balancing, and message routing. Example using configuration files, Python. Example config.ini*. This example demonstrates how to read server details from a configuration file, providing flexibility and making it easier to manage different server configurations. The use of try, except blocks provides robust error handling. The config parser module handles the complexities of parsing the ini file. Conclusion Bro joining the wrong server is a multifaceted problem with various potential causes. By understanding the fundamentals of client-server communication, employing effective debugging techniques, and adhering to best practices for configuration management, error handling, and security, you can build robust and reliable networked applications. Remember to focus on clear configuration, thorough testing, and informative error messages to make troubleshooting easier and prevent your clients from connecting to the wrong server.